In chemistry, quite often we are working with novel compounds for which we do not know the heats of formation. The problem then is that we want to be able to estimate the enthalpies of reactions involving these compounds without doing additional experiments. The bond enthalpy is defined as the enthalpy change required to break a particular bond in 1 mole of gaseous molecules. For example, for the hydrogen-hydrogen single bond, the bond enthalpy would be the reaction enthalpy for reacting hydrogen gas, H2, to form 2 hydrogen atoms. As you may expect, a double bond is stronger than a single bond, while a triple bond is stronger than a double bond. However, you do not expect, for instance, a carbon-carbon double bond to be twice the strength of a carbon-carbon single bond. This is because pi bonds are weaker than sigma bonds. Alas, life is not so simple. Bond enthalpies in fact depend on the context of the bond. For example, we can consider the OH single bond. To break off the first OH bond from water to form a hydrogen atom and a hydroxide radical takes 502 kilojoules. However, from a hydroxide radical, it takes only 427 kilojoules to break off the 2 individual atoms. So which of these is the bond enthalpy we use when we consider these problems? What we do is we report, and we can find in tables average bond enthalpies from those found in different compounds. For this reason, calculations involving bond enthalpies are estimates only. Recall that it takes energy to break bonds, and when bonds are formed, the enthalpy of the system decreases. What we can do, therefore, is to look at a reaction in this way. Consider the chlorination of methane, CH4, to form CH3Cl and HCl. The enthalpy of the system is increased because we break the CH and ClCl bonds. However, a corresponding decrease in the system's enthalpy is found when we realize that the HCl and CCl bonds are formed. Adding together these two contributions gives us the enthalpy change associated with the reaction. In order to estimate the reaction enthalpy for this gas phase reaction, we look at what bonds are formed and what bonds are broken. We draw out the Lewis structures for each of these compounds. Here, for clarity, I have omitted all lone pairs from the Lewis structures. From looking at this, we see that we break one chlorine-chlorine bond and one carbon-hydrogen bond. We form one carbon-chlorine bond and one hydrogen-chlorine bond. The reaction enthalpy, as seen from the enthalpy diagram we looked at before, can be estimated by taking the sum of the bond enthalpies for the bonds broken and subtracting the sum of the bond enthalpies for the bonds formed. The bonds that are broken are that of the carbon-hydrogen bond and the chlorine-chlorine bond, and the bonds that are formed are the carbon-chlorine bond and the hydrogen-chlorine bond. Substituting in tabulated values, we find that the reaction enthalpy is minus 104 kilojoules. Note that as these are based on average bond enthalpies, they are estimates only.